not letting me download very much stuff, and then when it starts, it gets all clogged up, so I have to wait forever and a day for it to get going again and delete a whole bunch of, anyway, yeah. So I haven't finished all of the preparation because I wasn't able to.
That's okay.
It'll make it short on your end.
I mean, most of it you just input into the Excel spreadsheets, and so it does most of the solving for you. You just got to know what information to use when.
So did you have any questions about it, or you're just doing the meeting because you're supposed to do the meeting?
Well, I'll always do the meeting whether I have questions or not.
It's true.
Just because it's part of the class and that's important. But I mean, I did have a question because I always, like I said a few weeks back, I was going to start taking the individual quizzes before we met as a group to check my understanding and see make sure I was going to be prepared to come to the group. And I did miss one. So
which one was that?
It was getting the margin of error with this new set of data that we've learned with these new t distributions.
Oh, Andy's not here to help us out.
And so, which is fine.
Are you sure?
Yeah, there was on the homework, but the answer wasn't given. Like, I don't know how much you're able to do, but like part 2, number 8 says with the data above, calculate the margin of error and create a 95% confidence interval. So I did all that, but I couldn't check my margin of error. Excuse me. And so I guess probably I just need to use the correct data. Let me think. The z-score, does that come up on our spreadsheet here? No z-score.
Well, isn't there a margin of error formula that we got last week that you could check it with?
Yes. However, that's the formula I used on the quiz, and I got it wrong. And so that was my concern. Everything else, in fact, I got a lot wrong the first try, but then I realized there was also the mistakes, and then I just missed one in the second try. But the margin of error is z with standard deviation divided by the square root of n. When I used that, it didn't work, so I'm wondering if we should use t. I wonder if
well, they're talking about t, so
yes,
can't help a whole lot, but I imagine if we did that
instead of the z-score, we use a t-score.
Yeah.
I wonder.
Let me look in the reading and see if they say anything.
Yeah, I couldn't find anything in the reading that specifically talked about that.
When they talked about it last, they wouldn't use the last beginning of the week's stuff, would they?
There was a lot. No.
There was a lot of margin of error around Tuesday.
Mm-hmm.
Would margins of error be considered the state of degrees of freedom?
No, degrees of freedom is very different.
Okay.
Your degree of freedom is just n-1, which is 1 less than the sample size. So that one's actually going to be really easy. It's always going to just be whatever your sample size is minus 1.
Maybe I should type it into Google. How do you do margins of error on biostatistics?
Well, I know how to do margin of error. It's finding the margin of error when for mu when standard deviation is unknown. Because that's what I was saying is I used the equation that I knew for margin of error. That's what I'm wondering is the margin of error equation is just merely the z-score times the standard deviation divided by the square root of n. So I wonder if it's just our t-score times the standard deviation divided by the square root of n, but we don't know the standard deviation. So I don't know. I don't know how that.
I did not do well on those margins of errors thing. I kept getting the wrong answer. There has to be a way to figure it out. I heard one time from a classmate that you could pop in the question in Google and they would tell you how to answer it. Ever tried that?
Yeah, I'm just looking over the notes, seeing if I can figure it out. Yeah, let's see, I don't know, because let's see here. Yeah, I'll just email the teacher. I'm sure it's going to be on our quiz here we're about to take. But
no, we have to find it.
I just all right, I'll just Google it and see if we can if it'll come up.
I typed it in.
Yeah, the problem, that's what I'm saying, is
It did not work.
I don't know it well enough to narrow it down to what I'm looking for, because it's super easy to get the regular margin of error, but I just don't know how to get it in these examples, and it doesn't talk about it at all in the reading, which is kind of frustrating. No. Which is fine, like I said, we'll just have to, or I'll just have to email her and then get back to you guys on Tuesday, or you can email her as well.
Well, I kind of already emailed her about my computer issues, but what's new?
She's just used to that by now, I'm sure.
Yeah, I'm sure she is. I had one thing that I had a difficult. Sometimes I have a hard time deciding between how to. So like if the null is bigger, with this hard time deciding how to, say the wholly reject the null because whatever. Never mind.
I know what you're saying.
I just get confused on which one to say and how to say it. Like I can do the work, but when it comes to writing it out, you're supposed to write out the
like as a sentence. Yeah. I don't think there's like any perfect way to write it. You're merely just, I think, writing it out like how you would read it with the alligators and the equal sign.
Yeah.
So for me, I would just say we failed to reject since the p-value was greater than the I'm blanking on what that term is, but the something value, we failed to reject the null hypothesis. I think it's as simple as that, or vice versa. Since the p-value was less than the so-and-so, I think it's sigma level, we do reject the null hypothesis.
Is the p-value basically the answer for
yeah, when we're right. Yeah, when we're talking about the rejecting or keeping the hypothesis, we're talking about the p-value. Correct.
So it's just the answer. It's just like saying p-value, they can't say the answer.
Well, the p-value is going to represent, typically our level is going to be that 0.05. And so if our p-value is less than 0.05, we do reject the null hypothesis. And if it's greater than 0.05, we fail to reject the null hypothesis.
Okay.
So I think it's just as simple as that. It's kind of like it's a law. Like, I don't know if you ever took geometry, but in geometry is the same thing.
No. I love math.
Well, yeah, I don't blame you. But I took geometry in like 10th grade, and so I had to do all that stuff back then.
Way back when.
What's that?
I said way back when.
Way back when, exactly.
Okay. That will probably help. Sorry, there's nothing I can help you with.
No, you're fine. I'm still looking to see. There's nothing about that dang. Maybe I'll try it on this quiz and see if we can get it right.
Okay. I really can't help with like the end of that quiz because I could open the Excel thing once and then but I can maybe help with the beginning of the quiz.
Sure. I mean, we'll figure it out together. That's why we have these meetings. So.
Okay.
And I'll be honest, I struggled quite a bit with this, and so I'm definitely going to be communicating with the instructor for a little guidance.
Oh, so am I.
Yeah, and so I think it's just trying to understand when we do what, but maybe I did figure it out somewhat from the personal quiz that I took. But we shall see, I suppose. Oh, 16 questions. Oh, joy.
Oh, no.
That makes sense.
Oh, look, the T-distribution atlas here, so I don't have to worry about not having it. That's exciting. That looks like Scotland colors.
It is. That's what it's based off of, I believe, or Ireland's. I think it's Ireland.
He works in Ireland. Yeah, that's right. Oops. Never mind.
Well, if we need it, we'll see. In previous lessons, are you there before I go on?
Yes.
All right. So in previous lessons, we had assumed the population standard deviation was known. In this lesson, we're making a different assumption about the standard deviation. What has changed? We assume that it's unknown.
It's unknown.
Good. Yep.
Yeah, I got one right. It's exciting.
So far, so good.
I read that part.
The next two questions, let the null and alternative hypothesis be null hypothesis is mu equals 8. The alternative hypothesis is mu is greater than 8. Assume that the population standard deviation is not known. Becca, hey, do you go by Becca or just Rebecca?
Usually Rebecca.
Yeah, I don't know if I've ever told you my wife's name is Rebecca.
Yes, she said, don't say her name that way.
Oh, that's right. And I
totally don't blame her. My husband said my name the same way as he said some other person he didn't even know name. I would not be very happy either.
She was just confused because I kept saying her name and she kept saying what? And I wasn't actually talking to her. But I call her Becca sometimes, though. Becca collects a sample of size n equals 9 and computes x to equal 11 and s to equal 6. Is the standard deviation known? No, it is not.
No, because that doesn't even make sense. Don't have all this stuff.
It says right in it, assume that the population standard deviation is not known. So.
Are we having the same number?
That's number 4.
Okay, good. Okay.
Yeah, but I'm saying right in the question, it says assume that the population standard deviation is not known.
Yeah.
So.
That helps, doesn't
it? Yeah. What is the value of t? Let's see here.
Okay, so the t, where did it say that? That's at the top.
So let's do some math.
T is what the z used to be, right?
Yes, so t equals the x bar minus mu, which is 8.
Which formula are we doing again?
This is
the one with the square root, right?
Yeah, for the t. This is what we just learned in the past 2 days. The student's t distribution. So t equals x bar minus mu over s divided by the square root of n. So s is 6 divided by the square root of 9. Got my handy dandy calculator.
11 is 2.
So 3.
9, I think this is maybe 3 is the square root of 9, right?
Yeah. So,
Okay, so 6 divided by 3 is 2 is 1, isn't it?
well, you have to do 11 minus 8 over 6
2.
divided by the square root of 9.
Yeah.
All right, I'm just typing in now just to double check. I let the calculator do it all.
I'm probably wrong.
So it's going to be 3 divided by, so 6 divided by 3 is 2. So 3 divided by 2 should be 1.5, right? 3 divided
Where'd you get the 3?
11 minus 8.
Oh, I was saying it was 2. That's why I was like, what? Sorry, I forgot how to subtract for a minute.
That's okay. 1.5. So
3 okay. I forgot how to subtract. Okay, that's lovely. Okay, use the information, use the following values which were pulled from the data file. Body temp for the next question.
oh, body temp.
Software. Can't use the software. It's still how much? It is about 80% loaded now.
Your software?
Yeah.
Oh, geez.
That's what happened before. Wrong stuff. And then I thought maybe I had too much stuff on my computer, so then I got rid of some stuff on my computer, and it still took a long time, and then I gave up on it, and I deleted the thing, and then it finally finished. But it was deleted, so I had to deal with that for a while. Obnoxious. Anyway, focusing. Sorry.
No, I that's super frustrating, I'll be honest.
Well, I can't use my software.
All right, I'll pull it up.
Thank you.
No problemo. Ready to return. Body. Whoa. Sounds like somebody just shot a gun outside of my house.
Where do you live?
Rancho Cordova, and it's in southeast Sacramento.
Some of my coworkers, because I commute, they hear gunshots a lot. Tacoma's not a very good place to work.
Oh, Tacoma, that's where you go to?
Yeah. That's where I go to work, yep.
Gotcha.
They have lockdown drills at least once a month.
Oh, jeez.
When I was a kid, I didn't even know what a lockdown drill was.
Did you grow up in Utah?
No.
Where'd you grow up?
Lacey, Washington. It was a smaller town. We didn't have to worry about lockdown drills.
Oh, that's nice.
So the first time I was subbing at a school in Tacoma that had one, I was like, what do we do?
Yeah. Oh, man. So it's...
Sorry. I'm very easily distracted.
It just happened again. What the heck is going on? Jeez. Maybe it's somebody just throwing something into the garbage can. I don't know. You heard that?
Yeah. Sounds like someone's letting off fireworks.
Yeah, it sounds more like fireworks than gunshot, huh? I was thinking maybe they're throwing something into the garbage. It's hitting the bottom. Just really loud.
Well, the first one sounded like a gunshot. The second one sounded like a firework.
98.6.
Do you guys have dogs?
Oh, no dogs, but I bet you if we
live in dangerous areas, I'm telling you, dogs are amazing. People cross the street so they don't have to walk next to me when I have my dog.
Wow, that is nice.
That's awesome.
All right, so use the following values which are pulled for, okay. Copy and paste them into your software. Use a null hypothesis, okay. A level of significance, gotcha. So what is x? X is, and bear with me, if I get all these wrong, it's because I didn't have any help, and I...
It will be better than what I got, because mine would be all guesswork. I can't think something, so, your answer is way better than mine.
No, yeah, less than equals to, mu is less than, okay. Less than, okay. Let me see. All right, so our x bar is going to be 98.24. 234.
So that was 98.234.
Yes.
What is the S?
Our S is going to be,
That was the old standard deviation, right?
yeah, so it's going to be 0.
Why do they have to change things? Why can't you just tell us the normal one first?
You're computing different things with different variables. So the answer to that one, what is yet S, is going to be 0.738.
And T-score used to be the Z, right?
Correct, yeah. And so our T-score, our T-score is going to be negative 6.029.
Do we have to do any of that in the little applet thing they gave us?
No, none of those thus far.
Okay. So now that they gave us all that, do we have to do an equation for the p-value, or is that shown in the...
P-value is also solved in our Excel spreadsheet. So.
Oh, that'd be lovely.
But it gives us a crazy number.
Oh no.
6, so it's going to be, oh, it's really small. Yikes.
Oh, the teacher told me that if the area section on the applet says something, something, something E,
yeah,
but you just put 0. Because it's so small, you just put 0.
For the answer?
Yep.
All right. Yeah, because it really is. If we're rounding to 3 decimal places, it's going to be rounded up, rounded to 0, yeah. Because it's going to be, it's 6 point, well, let's write this out. This brings me back to like 3rd grade. I can't even remember how to do this. 6.36148 e to the negative 9. So 1, 2, 3, 4, 5, 6. Yeah, it'd be 0.
Did I help in something today?
Yeah, no, that's great that you knew that. I mean, I would have figured that out because when you write it all out, the first 3 numbers are all zeros, so it'd be rounded to 0.
Anytime you look at something in the applet and it says E, though, that means it's so small you just put 0.
Well, this isn't in the applet. This is on the t-test spreadsheet.
Well, fine. Yeah. Okay, so what is the...
So it might be 0.001. I wonder. Sorry, I'm computing over here.
It sounds like a game. A little Pac-Man game or something. Yay! It showed up.
It downloaded?
Just the one sample t-test for memes. Is that one we're supposed to use?
Okay, yeah, it's definitely 0. I just did the scientific notation. It's been a long time since I've done that.
So number 10 would be fail to reject, right? Because they were so close.
No, we do, because we reject the null hypothesis because it is below 0.05.
Oh.
Remember,
Okay.
it's
That's
just
one
one.
of the things I'm confused about. So we reject it if it's below.
Yeah, just write it down. It's always going to be the case. Always, always, always.
I am writing it down.
Okay.
Let's see. I think that's partly why I get some of them wrong, because I was looking to see that they were lower than the null, but they weren't like below 0.05. So then I was like, oh, well, then it's fine.
Yeah, we're always just using the 0.05 as our reference there. So whenever it's below 0.05, 100% of the time, you're going to reject the null hypothesis. When it's above 0.05, you're going to fail to reject the null hypothesis.
Okay. The hospital claims its average time between births is 40 minutes and Zan's resource location based on its claim. You want to test it by you select level significance. So my thing's finally running. So are we on that spreadsheet that says one sample t-test for means? The top?
Yes. Yeah.
Okay. And where do I put all this lovely stuff? In the variable 1 column?
Yeah, you'll just copy and paste it into there.
Do I have to delete the 5, 10, 15, 20, 15, 18?
Yes, absolutely.
This is exciting. I can actually do something. Maybe I can get my homework done.
But see, did you notice our level of that's what it's called, level of significance. Our level of significance is 0.01, and so that's the null hypothesis that we're looking to reject. Or reject or accept, I should say. Or sorry.
Well, now I know why it's taking you so long. You had to type each one of them in.
No, that's not what's taking me long. I actually just, I was making sure that that 0 was correct.
Oh.
No, you can actually go, if you have the lessons open, you can just download the spreadsheet where they're already in, and then you just copy and paste.
That's not copy pasting.
Baby boom. But the way yours goes, I would not count on that because I'm going to take the rest of the day.
Fine.
But I will go ahead and do it if you want to keep entering in by hand.
Sure.
All right,
how many is there?
There are, let's see, there's just 45.
Just 45.
Just 45,
okay.
Yeah. Just 45.
Well, I'll get there when you're old and gray.
Average time between births is what we're looking for. Minutes. Wait. Use a following value for the next 6 values are the wait time in minutes between births. Wait times. Oh, crap. Oh, 59. Oh, 59 minutes. I got you. Because there's no.
I'm at 47. We'll be down in a minute.
So 28 is the last one, and 59 is the first one. Good. Cool.
All right. So I have all mine typed in.
Perfect.
What do we need first?
I don't know. What does the first question ask?
Why isn't the summary statistics filled in with the mean, standard deviation, and in?
I don't know. It doesn't fill in ever, so I don't know.
Oh, okay. I feel better now.
So
All right. What is the p-value?
It's gonna be 3. It's gonna be 0 again.
Where? Oh, yep, sure will. Can I find the next answer?
Of course.
Because I finally got it to work, so it's exciting. But, what decision do you make? Come on. You failed to reject it, right? Because it's not enough there to reject or non-reject.
Correct. No, sorry, we reject it. Sorry, I thought you were gonna write that down.
I did, but I still don't understand it.
So what's our level of significance?
0.01.
All right, so does 3.015 to the negative 18th, is that a smaller number than 0.01?
Yes.
All right.
So we reject it, right?
Every time, absolutely.
Sorry.
No, that's fine. It's important. It's an easy principle to understand, and so as long as you understand it, you're always going to get it right on the test, which is important.
What? Where would the 40 go then? To number 13.
Oh.
If it stays the same, but you have I'm confused on that one.
Oh. So see where it's the type of test?
Oh, do we have a different type of test now?
Yeah, so make sure on that last one you had not equal to as our type of test. So when you put in not equals to, I didn't have it in, so I would have missed it, but.
What? Not equal to? What do you mean what not equal to?
So it's that drop down in that box underneath your null hypothesis.
Mm-hmm.
Oh, you also have to put in your null hypothesis, which is 40. Oh, much better. Okay. That makes a lot more sense. That makes it feel better. All right, so what's our null hypothesis?
Well, is the confidence level still 95?
No, it's going to be 99.99.
99. Where did it say that?
So
did I miss it?
Our level of significance is 0.01, which means our confidence level is 99%.
Oh.
Yeah, so if it was 0.05, it would be 95, and if it was 0.1, it would be 0.90.
Oh. I'm gonna write that down.
Yeah, so this is a good teaching moment, learning moment for myself, is that before I look at numbers in our boxes, I should make sure that our confidence level, our null hypothesis, and the type of test is inserted into those boxes correctly, because it affected our numbers significantly. Because now our p-value for not equal to is actually 0.142.
Mine says something else. So what did I enter weird?
For your for your confidence level, do you have 0.99?
Yeah.
In your null hypothesis, you have 40?
Yeah.
In your type of test, you have not equal to?
Oh. No. So spell out literally not equal to?
No, it should be a drop down menu. If you click on the box, it'll give you an arrow to the right, and then you click which one.
Oh, one of those.
Yes.
Not equal to. Oh.
Yep,
Oh,
there you go.
My p-value says 0.97020.
0.97.
Yeah.
New. What is your N? Your variable one N?
27.
Okay. So interesting.
Did I miss typing in something though? Maybe I did. Oh, because they only gave me 31 numbers, so I missed some numbers.
No, that's crap. So, oh man. So yeah, I have 43, but that's because I copy and pasted it. They want us to insert them in by hand. 37, 62, and then they go all the way to 61. So they just want us to put in the 25 numbers.
Just 25, so they take the other ones off?
Yeah, so we're gonna have to go back and redo the last problem too here in just a sec.
No, I don't like that.
Because I messed up. I'm sorry.
It's not your fault. So 25 numbers we want?
Not even 25. They'll be starting with 59. You should go all the way to the 25th cell and end of 61. And so there's actually.
How is that possible? There's nothing there.
Sorry, I'm talking about our values. So we're only using the values that they give us in this quiz. So on the variable one on the far left-hand side for our values, we're just going to put in what the computer has. So 59, 14, 37, 62, 68, 2, 15, 9, 157, 27, 37, 2, 55. You with me?
Huh? Oh, you mean on the variable blue thingamajiggy, right?
So are you looking at the one sample t-test for means page?
Yes.
All right. And so on the left-hand side where it says variable one, and then we put in the numbers beneath it.
Yeah.
You just put in the numbers that were on the quiz, correct?
Yeah.
Okay. So that I did not. So that's why our numbers were different. So your N value should be 21, yes?
Well, I deleted some of them because I thought you said I was supposed to. Okay, now I got it. My N is 27.
How did you get 27?
I don't know. I just popped it into the computer.
Because there's only 21 values of the quiz on the quiz. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21. Yeah. Yeah. So your first on your variable one column, your first number should be 59 and your last number should be 61.
It is.
Okay.
That's weird, isn't it?
What's your p-value?
My p-value, I have to find it just a sec. It's 0.97020.
Yeah, so read the numbers that you have in your variable one column.
Did I put too many in?
You did, yes.
At 59,
Okay.
14.
Okay, just roll them off, yeah.
Okay, 59, 14, 37, 62, 68, 2, 15, 9, 157, 27, 37, 2, 15, 9,
Where'd you get
157.
Where'd you get 15?
That's what I typed in.
Well, there's no 15.
Okay, so take the 15 out.
Yes, so it should be 27, 37, 2, 55, 86.
Oh, you know what I did? Okay, so I put too many of them in. Okay, so 86 is next, yes?
Yes, 37, 2, yeah, 4, 40, 36, 47, 9, and 61.
40. Somehow, some of them got put in more. 9, and what was the last one? 61.
61. I'm getting these values right from the quiz. So these are the values they gave us on the quiz.
Well, that's where I got it from too.
Well, you forgot to delete the ones that were in there prematurely, like the 515.
No, I did.
All right. Well, I don't know where
I
that
don't
came
know
from.
what. I don't either.
I don't know to tell you. But
Okay, so
you should have 21 for n now, correct?
Yes.
And your p-value is 0.995.
Yes.
Okay, so to make sure we
Is
put
that
that.
our answer?
Yes, 0.995 is rounded. Yeah.
And that's the answer for.
That's 11.
Oh, we're doing that again. Okay, 0.995.
Yep.
Okay.
So since that is above 0.05, what?
Then we fail to reject it.
Perfect. There you go. Excellent.
Time is. So we used 40. Oh, okay. So we used 40.
So the only thing that's going to change is we're going to do less than as our type of test as opposed to not equal to.
So I switch it to less than, but everything else stays the same.
Yes, and that decreases our p-value because look at your p-value.
Certainly does a lot.
Yeah, so like you got 0.502 as the new p-value.
Yep.
Perfect. So with this, what decision do we make?
5, 0, 2. Well, it's still bigger than the 0.1.
Right.
So yes, let me read it.
Mm-hmm.
So we keep it. We fail to reject. Yes.
Good. Yeah.
Yes.
Yes. Fail to reject.
Yay! Okay. Now construct the 95% confidence interval for the true mean wait time between bursts possible. So we have to go to the confidence level and do 95, right? Instead of 90.
Excellent. Look at you go.
I'm trying to learn.
You could be teaching the class.
Okay. What is the lower limit of this confidence level? Where do you find the lower?
It tells us in our spreadsheet there.
Standard, I mean, p-val, confidence. Where's it say lower?
Well, our confidence interval, and then it's going to be the lower value. And we're rounding to 1 decimal point. On our spreadsheet, there's a confidence interval and it gives us our low and our high. Those are our answers.
I only see. Where does it say that? Because I'm only seeing one little box that says confidence level. Oh, the confidence interval?
Yes.
Oh.
Like in the question where it says, what is the lower limit of the confidence interval? You find that in the confidence interval boxes.
So that's, yes, it's funny. That's 23.499, right?
Yeah, but 23.5 around it. That was me being condescending if you didn't catch my my tone.
That's why I said yes, that's very funny.
But
they used a different word. They didn't use level. They said interval. It's late at night. Come on.
8:18 is late?
Yes.
Oh.
My brain stops at 7.
Fair enough.
The upper one, so I can pass my teacher, 56.6. Yes?
Good. Very good.
Oh boy. Should we submit it?
No. Because I messed up on the other end, remember? Because I put in all of the values in the data in that first set of problems, but we were only supposed to use limited data that they provided. Well, I'm re-entering it now. In fact, you can do the same as practice. Now you can do it with me.
Oh, what am I supposed to be doing?
Go up to problem number 6, and then put in all that data into your variable one side.
Okay, so type all those in?
Yeah.
small again so I can see it. 97.6.
You can't do it out loud because I'm doing it as well, and it's messing me up.
Sorry. Okay, tell me when you get there.
I'm there. I'm filling in the answers now.
So are we looking for X? Are we looking for those ones all over again?
Yeah. So
Where's the X?
X bar is our sample mean.
I don't even see sample mean on here.
Well, we just put in our sample, and so it calculated our sample mean in the mean.
Oh, so I just look up for mean. Gotcha.
Yeah, so we put in the sample, and so that is our sample mean.
That makes a little too much sense, I guess.
And
98.220. What'd you get?
Yep, that's what I got.
Okay. We're down 98.220. You're only 2 numbers off.
Yeah, but the next two were really off, so it was very important that we came back and fixed it.
Where's the S? Which one's the S?
It's our standard deviation.
Oh, I gotta memorize this. I think I get it, and then I forget. Okay, so 0.922. Is that what you got?
0.922, absolutely.
T-score is, big difference. Huge difference.
What was your T-score?
I got 282.391.
Your T?
T is in toy.
You got 200 something?
Yeah.
That's wrong.
Okay, Your Royal Highness, what did I do wrong?
I don't know. Your mean and your standard deviation are right. How the heck did you get?
I don't know.
Is your confidence level at 0.95?
Yeah.
Is your null hypothesis at 98.6?
No.
Oh, well, there you have it.
Where did you get that from?
Because that's in the question.
All right.
The null hypothesis is that it's 98.6, and our alternative hypothesis is that it's less than 98.6.
So the stuff they give us is going to fill out the small box with the confidence level and null hypothesis.
Yes.
Yes?
Yes, 100%.
And then we fill in the variables, and then they give us the rest of the answers, right?
Absolutely.
Okay.
So you can see how much of a difference it makes when you have the wrong null hypothesis in there.
How large difference
Yes. And then your type of test is less than, correct?
The type of test, yes.
Okay. So now what's your T-score?
Negative 1.843.
Ah, much better. Much better.
Yay. So then the p-value would be not 0 this time.
Right.
0.040.
Yep. Ironically, we still got question 10 correct. Because
Okay.
why? Why did we get it right?
Now you have to make me go back to it. Number 10. What is correct decision based on that? Well, they want a 0.5 or 0.05, and the answer was 0.04, and it's less than a 0.5, so we reject it.
Perfect.
Because I wrote that down on paper, just like you said.
Perfect.
Reject the null.
Reject the null. Now let's see if we got them all wrong again. Everything I just taught you is
All right.
incorrect. Let's see. I'll submit it and see what we got.
Well, one of mine will be, because I didn't finish the homework.
Oh, 100%, baby. All right.
All right. Now, can I just make sure that mine is only one wrong? Because
No.
last time
You got to submit it, and then if you get one wrong, I'll tell you what the right one was.
I did submit it. Okay.
Oh, and you
We're
did
good.
you got 100%?
Yeah, well, except the first one, but that's not your fault.
Oh, okay.
It's in my homework. It's great.
Gotcha.
Thank you for teaching me how to do the spreadsheet. That was nice.
No, you did really well. I think the biggest thing to learn is that, but for both of us, is that make sure that confidence level, null hypothesis, and type of test are inserted in there correctly. Because if not, we're going to get the wrong answer. And
yes, we do.
because everything else is computed for us, which is super nice. But if we don't do that, and just as a heads up on the personal quiz or whatever, it's the same thing. If you put in the wrong, if you don't have those in correctly, they're all going to be wrong. So
Okay.
But my word of advice is only use this spreadsheet for the personal quiz. Only use the one sample t-test for means to get your answers. Don't use any other spreadsheets that will get that compute things for you.
Yes, because when I used the one that we got in the beginning of the year, all of my answers were wrong.
Yeah, don't use that one. That will get you wrong answers. Just
They
use
didn't
this
tell
one.
us, oh, this one expired. Don't use it again.
Yeah, I don't. Yeah.
Thank you for telling me.
Yeah,
So don't get right answers.
that's all. That's all I'll tell you on that. But I think you did really well. So I think you'll do well on the quiz. But I think that's it for us. Let me.
Thank you.
Yeah, I'll plan on talking to you on Tuesday. All right.
Yep.
All right. I'll see ya.
Have a nice evening.
All
Bye.
right. You too. Bye bye.